Esters are a class of organic compounds which are derived from carboxylic acids. Do you know esters are the reason for the sweet smell of fruits and the fragrance of flowers? Since they are volatile and since they have nice smell and also many other good properties, esters are widely used in day-to-day life applications. They are excellent solvents and they are used in making perfumes and many other things. There is another set of esters which are not volatile and also not sweet smelling. Do you know what are they? They are well known to us in day-to-day life activities as well. They are none other than fat and oil. Yes, coconut oil used in cooking, vegetable oil are also esters. Animal fat is also an ester. So because both oil and fat are coming under class of lipids, which are esters. Let's see how do we write the formation esters from carboxylic acids. Carboxylic acids and alcohols react to produce esters and water in the presence of concentrated sulfuric acid and when we heat the mixture. Here is an example. Ethanoic reacts with methanol in the presence of concentrated sulfuric acid when we heat the mixture to produce the ester called methyl ethanoate and the byproduct water. But how can we write this reaction properly? How do we draw the formula of the ester? Let me explain you. First, you write the displayed formula of the acid. Here is the ethanoic acid. Now, you are going to draw the formula of the alcohol, but it's drawn reverse. But I'm going to draw OH like this. The bond is slanted so that we can easily understand the formation of water. And now we have the methyl group. You can see the OH from the carboxylic acid and the H from the alcohol combine to form water molecule as the byproduct. And here I am going to draw the displayed formula of the ester you obtain. This is the part. What is drawn in black is the part coming from the carboxylic acid. In the blue, it is the alcohol part. So, this linkage is called ester linkage. It's easy to understand the structure of ester molecule. It has the ester linkage, and one side you have the carboxylic acid part, the other side came from the alcohol. Okay, now we'll see how to write the name of the ester. Name of the ester follows this basic format. It is alkyl carboxylate. Whatever the part came from the alcohol will be written first with the suffix of "-il", and the part came from the carboxylic acid written with the suffix of "-ate". Now if you go to this example, so it was made from ethanoic acid and methanol. As a result of that methanol, we write methyl. Ethanoic acid, therefore we write ethanoate. So the name of this ester is methyl ethanoate. Let's have a look at its condensed formula. See whether you can understand the structure from its name. Let's try to figure out the ester bond, COO, and the part came from the alcohol side. You have only one carbon, so it's methyl, and you have the part came from the carboxylic acid, which is ethanoate. Let's do our second example. Propanoic butanoic acid and ethanol. 3 carbon atom carboxylic acid, 2 carbon atom alcohol. And see how the OH group and the H are going to combine to form water, and the carbonyl group or the carbon oxygen double bond group is going to combine to the oxygen atom of the alcohol. And you have 3 carbon atoms in the carboxylic acid side and 2 carbon atoms in the alcohol side. How do we figure out which part came from the carboxylic acid? Obviously, it is the part where you have carbon-oxygen double bond. Or it is the part where carbon has oxygen attached not through a single bond. How do you know whether it's a single bond or not? Just see whether you have 2 groups around it. If you have 4 groups, then it's going to be a single bond. If you don't have 4 groups, then that part can be the carboxylic acid part. Alright, so here we have the carboxylic acid part and the alcohol. So it's ethyl propanoate. I know you have understood how to write the ester molecule now. So why not you try the next example? Butanoic acid, propanol. By now, you will be easily finding the name of the ester through that format. So if it is butanoic acid and propanol, then the ester will be propyl butanoate. So let's take a few minutes and try to write the formula and get back to the video. Are you done with your answer? Let's have a look at the answer. Butanoic acid, 4 carbon atom carboxylic acid, propanol, 3 carbon atom alcohol. See how the water molecule is removed. Here we have the ester. Here we go the ester linkage. And from this side we have the butanoic acid part. You have 4 carbon atoms, and that side you have 3 carbon atoms came from the alcohol. Even though the name is written by taking the alcohol first, it is not a must to draw the alcohol first and the carboxylic acid next, because the name format is fixed. It should be alkyl carboxylate. Let's get more familiarized with these esters formulae. Here are the 3 esters we just did. Methyl ethanoate, ethyl propanoate, propyl butanoate. I have drawn the same ester but reverse. See, we have the ester linkage here, but now I have put the alcohol part first. You have 1 carbon atom, which is methyl, and 2 carbon atom, which is ethanoate. So it goes with the name methyl ethanoate. So why not you try these 2 and get back to the video. Okay, here are the 2 answers. Check whether the structures that you drew are correct with these 2 structures I have done. Do we have to write the balance equation always to find the structure of ester? Actually not. It can be done easily. Let me explain you how to do that. Suppose you are given a name of an ester so that you need to draw the structure of it. So what you can do is start with your ester linkage. Ester linkage is always C double bond O, CO. And don't forget, your carbonyl group or the carbon oxygen double bond side should be from the carboxylic acid. Carboxylic acid. The other side is going to be from the alcohol. Since you remember how the name is written, you can quickly figure out the alcohol and the carboxylic acid. Methyl means it should be methanol. Propanoate means it should be propanoic acid. Therefore, now you know this side is going to have, now you know this side going to have 3 carbon atoms because propanoic. So you draw 2 more. Don't forget, you have 1 carbon already. So it's going to look like this. It's going to look like this. And the alcohol side, you need to have only 1 carbon because it's methanol. So let me draw 1 carbon. Here we get your ester, methyl propanoate. We'll try this. Ethyl methanoate. So first you draw the ester group, ester linkage, and make the decision. Ethyl means the alcohol part. It has only 2 carbon. Alcohol part is where you have single bonded oxygen side. So put 2 carbon atoms. And the methanoate part. Remember, when methanoic acid is involved, it's always tricky because it has only 1 carbon atom and the remaining will be hydrogen apart from its carboxylic group. So here we have the carbon of methanoic and just 1 hydrogen. Look, when I write the condensed formula, it's slightly different from the others. You have this H this side. Let me condense further. You get HCO2, C2, H5, ethyl methanoate. So far in the lesson, you learned how to write the balanced chemical equation for the formation of an ester from carboxylic acids and alcohol. Also, you learned how to write the formula of an ester directly starting from the name. Now, let's move into certain other important features of these reactions. First of all, the most important thing regarding this reaction is that it is a condensation reaction. You can see 2 organic molecules combine with the loss of small molecule, forming a larger organic compound. Such reactions are called condensation reactions. Esterification is a condensation reaction. Second, concentrated sulfuric is acting as a catalyst. Because this reaction has high activation energy, you have to use a catalyst as well as the heating is necessary in order to overcome the activation energy barrier. Thirdly, we have this reaction as a reversible reaction, which means it won't give you 100% yield. There is always some acid and the alcohol will be remaining at the end of the reaction. However, change in the conditions, you can make more and more ester to be produced. Now you know the esterification reaction and its details related to your syllabus. So you can take your crash course tube and start the respective pages mentioned at the end of this video and complete it as soon as you can. Hope you enjoyed this video and learned about esters in detail. Thank you.